Look at the American Cordillera. It stretches continuously from Alaska all the way down to the southern tip of Argentina. These peaks form the geographic spine of the hemisphere. They also act as a massive geological sorting mechanism. Every single raindrop that falls on the Americas is directed by this continental divide, either sent washing down the western slopes into the Pacific or rolling eastward toward the Atlantic. It is an absolute law of gravity, with exactly one geographic anomaly. Deep in Wyoming, North Two Ocean Creek flows right up to the exact ridgeline and splits perfectly in half. One channel heads west, the other east. But the vast majority of water flowing off those eastern slopes gathers into massive, continent-spanning catchments. In North America, that creates the Mississippi. In South America, it feeds the Amazon and the Paraná. South America possesses the largest river by volume on Earth. Yet, it was the Mississippi Basin in the north that powered the expansion of a global economic superpower. The North American interior is deeply interconnected. Ships can load up in the American Midwest and carry massive amounts of freight through the Great Lakes, straight out the St. Lawrence River and into the Atlantic Ocean. This cross-section elevation chart shows exactly where the real mathematical advantage lies. Compared to typical rivers, the Mississippi has a remarkably flat gradient. That creates an average surface speed of just 1.2 miles per hour. It flows at a walking pace. And this perfectly calm, extremely wide transit corridor happens to sit directly on top of the largest contiguous piece of arable farmland on the planet. Because the water is so flat, you don't need highly specialized deep draft ships to move massive amounts of weight. A standard barge tow on the Mississippi will routinely string together 15 separate cargo holds into one massive floating block. This data visualization shows how that translates to raw efficiency. A single 15-barge tow carries the exact same amount of freight as 1,050 semi-trucks, or 216 railcars. Moving that much weight on roads or rails destroys concrete and steel over time, but a slow-moving, low-elevation river causes minimal erosion to its banks and locks, keeping maintenance costs low. The United States inherited a rare alignment of natural features, a high-capacity, free-flowing transit grid built directly into its primary agricultural zone. By comparison, South America's Amazon River completely dwarfs the Mississippi. In terms of sheer water discharge, it is a monster cutting through the continent. But the surrounding environment makes that water difficult to use for heavy commerce. The river is choked by dense, ecologically sensitive rainforest that restricts the construction of large-scale concrete infrastructure. Because of that heavily forested course, there is not a single bridge spanning the Amazon River. That lack of permanent connectivity holds the river's annual freight traffic at just 25 million tons. The southern alternative is the Paraná River. It runs for nearly 5,000 kilometers and physically borders Brazil, Argentina, and Paraguay. But it is riddled with natural rapids and severe choke points. The Itaipu Dam, for instance, spans the entire waterway to generate hydroelectric power, physically blocking continuous boat travel. Fixing those unnavigable sections requires massive capital for bypassing locks. And because the river serves as an international border, every upgrade requires multiple rival nations to agree on funding and construction, which frequently stalls progress. A massive volume of water does not build wealth on its own. If terrain and borders actively prevent continuous transit, the economic utility remains severely constrained by its own environment. But the natural head start the United States enjoyed for centuries is currently failing from within. This gauge shows the current lifespan of America's inland waterway infrastructure. Right now, over 80% of the nation's lock chambers have exceeded their engineered design life. At the same time, the system is facing a threat engineers cannot fix with fresh concrete: extreme climate shifts. Successive multi-year droughts are actively shrinking the river's flow. In both 2012 and 2022, water levels dropped so low that massive fleets of barges were bottlenecked and stranded against exposed riverbanks, costing the economy billions of dollars in halted trade. Currently, 92% of America's agricultural exports rely on the Mississippi Basin to reach global markets. Failing infrastructure and shrinking water levels put nearly all of that freight at risk. While the U.S. struggles to fund lock repairs, competing nations have aggressively modernized. China rapidly develops the Yangtze River, lining it with nearly 4,000 cargo berths and integrating it directly into their major industrial hubs. This bar chart compares the results. The Mississippi moves a respectable 630 million tons of freight annually. The Yangtze is currently moving 2.6 billion tons. And that strategy is exporting. Foreign capital is now pouring into Southeast Asia's Mekong River to blast rapids and build modern locks, attempting to replicate the inland shipping boom. Geography provides the foundational structural advantage, but maintaining a superpower economy requires continuous human investment, because the rivers will keep flowing, whether the barges can navigate them or not.